Hello and welcome to the 6th of our ACCA F5 lecture recaps. This one was on linear programming. So what is linear programming? Well, it's a problem-solving technique. So the two problems that we are talking about are the production mix to maximize profit. So what should you produce to maximize your profit? And the production mix to minimize your costs. What should you produce to minimize costs? There will be constraints involved. So constraints might be limited raw materials, limited labor hours, or limited machine hours. The best way to do this is to look at a question. So we looked at our question that involved our designer shoes and trainers being our two products. We had a maximum of 500 machine hours and a maximum demand of 150 pairs of either designer shoes or trainers. The machine hours taken to make each were designer shoes took 2 machine hours, trainers took 5 machine hours. Profit per unit was $50 for designer shoes and $30 for trainers. Best way in the exam is to set that all out in a little list so you can pick each bit out easily. So step one was to define our variables. So what we needed to do was say, right, what can we control? Can we control demand? No. Can we control machine hours? No. We can control what we actually make. Okay, so that's what we can control. We're going to take each item that we can control and we're going to call one X and the other Y. So we call designer shoes X and trainers Y. That brought us on to step two. Step two was to establish the constraints. So the constraints we were told about were machine hours first of all. We're told that X takes 5 hours to produce, Y takes 2 hours. The maximum machine hours available are 500. So 5X plus 2Y must be less than or equal to 500. It can't be any more than that. Okay, so 5X plus 2Y must be less than or equal to 500. Demand, well, it's all for either X or Y. So all the demand is for shoes or designer shoes or trainers. The maximum demand is 150, so X plus Y must be less than or equal to 150. Remember your non-negativity, half a mark for this in the exam. You can't produce less than naught, so X must be greater than naught and also Y must be greater than naught as well. So get that down in the exam because you get an extra half mark for it. Step three, you need to establish your objective function. So what is your objective? In this case, our objective is to maximize profit. We want to maximize the profit that we can generate. Okay, so you need to look at the profit per unit and set it out like this. The profit will equal 50x plus 30y. So we can make $50 per designer shoe set and we can make $30 per set of trainers. Okay, so that's our objective function. The next step is to graph our constraints. So how do we do that? Well, we take each constraint and we say, first of all, what is X if Y equals 0? So we say that Y equals 0, and if so, if Y equals 0, then 5X equals 500. So that means that X equals 100. So that will be the plot point on our X axis. X equals 100. We then say, what is Y if X is 0? So if X is 0, then 2Y equals 500. So that means that Y would be equal to 250. So again, that's the plot point on our Y axis, 250. So that's how we plot the constraint 5X plus 2Y equals 500. The two plot points will be X equals 100 and Y equals 250. The next constraint was X plus Y equals 150. So if X equals 0, then Y equals 150, and if Y equals 0, then X equals 150. So that's how we graph any constraints. We set X to 0 and then Y to 0 and see what the other item is. So that enables us to do our graph, and this is what it turns out like. So we've established our graph. Remember that the feasible area will be the area within the constraints. So within the red and blue line up to the intersection. Okay, so that's the feasible area. The non-feasible area sits outside the constraint lines because remember those lines are constraining your production. Okay, so your maximum profit will lie somewhere at the intersection between those two lines, or potentially at the intersection of the X or Y axes. So you need to find out where your maximum level of production is, or your profit maximizing level. So we've established our feasible area. We then need to establish the profit maximizing point of production. So we can use an ISO profit line. So how do you do this? You choose a profit target. So say 2000, you're going to have to just judge by the figures that you're given in the exam. So we're going to choose 2000 in this. We're going to set that into our objective function, which was our profit equals 50x plus 30y. So we've said that our profit is 2000. So 50x plus 30y equals 2000. We're then going to graph this. Okay, so solve that equation to put it on the graph. If x equals 0, then 30y equals 2000, which means that y equals 67. If y equals 0, then 50x equals 2000, so x equals 40. So we then need to graph that ISO profit line. So we graph the ISO profit line and we move it outwards on our graph. Okay, so looking back at our graph, we need to move it outwards. We plot the ISO profit line. We then move it out parallel using our ruler. And at the outermost point where the two lines intersect, that will be our profit maximizing point. Okay, so you move it out, plot it on the graph, move your ruler out parallel with the ISO profit line, and where the two lines intersect, as far out as possible, that will be your profit maximizing point. So the optimal solution will be that point. At that point, we need to do a simultaneous equation to work out how much profit we're going to make. Okay, so we take the two equations, the two constraints, number 1 and number 2 at the top there. We're going to multiply equation 2 by 2 to get 2x plus 2y equals 300. That will enable us to get rid of the y's. So we subtract equation 1 from equation 3 that we just calculated. So 2x from 5x equals 3x. 2y from 2y equals nothing. So 3x equals 500 less 300 equals 200. So 3x equals 200. So x equals 67. We fill that into equation 2. So we have x equals 67 plus y equals 150. So that tells us that y equals 83. So our optimal solution is to produce x at 67 and y at 83. So that's 67 sets of designer shoes and 83 sets of trainers. Or you can use the ISO profit line to determine that. So that was the first of our sessions on linear programming. There's another one just to finish it off with shadow pricing. But that is the first of them.